Hello everyone. Today we will make revision about the two lessons 6.2 properties of the parallelograms and 6.4 properties of rhombus, rectangles and squares. The parallelogram is a quadrilateral with opposite sides are parallel. Each two opposite sides are parallel and each two opposite angles, the cross angles, are congruent and each two consecutive angles are supplementary. Their sum 180 and each two opposite sides are congruent. And the diagonals, the side that connects the opposite angles, the diagonals bisect each others. Here, let's solve this question. Measure of angle P. How to find the measure of angle P in this parallelogram? Since we have angle S is 64 degree and angle P, both of them P and S consecutive angles, then we can find the measure of angle P by subtracting angle X from angle S from 180. Then measure of angle P equal 180 minus 64 equal 116. The second question, suppose you adjust the lamp so that measure of angle S 86. What is measure of angle R? Also measure of angle S and measure of angle R, both of them consecutive angles. Then measure of angle R, to find measure of angle R, we will subtract the measure of angle S 86 from 180 to get that measure of angle R equal 94. How to solve the system of linear equations according to the properties and theorem that we explained. Here this is parallelogram, KLMN is parallelogram. And here we have two diagonals, and as we said, the two diagonals bisect each other. That means the diagonal divided into two equal halves, and the other diagonal KM also divided into two equal halves. Then the first equation, that y plus 10 equal 2x plus 8, and the other equation that x equal y plus 2. Let's solve this system of equation. By using the second equation, y plus 2 equal x, to solving the first equation, we will make substitution in the first equation. Y plus 10 equal 2. Instead of x, we will put y plus 2, this equation. Then y plus 10 equal 2. Instead of this x, I will put y plus 2 minus 8. Then using a distributive property, then y plus 10 equal 2y plus 4 minus 8. By solving this equation, then y plus 10 equal 2y minus 4. By moving y to the other side, by combining the like, then 2y minus y equal 10 plus 4, then y equal 14. After solving for y, after finding the value of y equal 14, we can make substitution in any equation. Let's solve the second one, the easiest one. Y plus 2, then 14 plus 2 equal x, then x equal 16. Let's find the side km and ln. Here km, this km, we said y is 14, then 14 plus 10 is 28, is 24, then 24 plus 24 is 48. The same as the other side ln, we said x is 16, then 16 plus 16 equal 32. Let's solve the next one. Find the values of x and y. What are PR and SQ? Also, this is parallelogram. By the same idea, we know that the two diagonals bisect each others. That means x plus 1 equal y, and 3y minus 7 equal 2x. Y equal x plus 1. Then by solving the first equation using the second one, we know that y equal x plus 1. We will make substitution in the first equation. Then 3y, instead of y, I will put 3 multiply x plus 1 minus 7 equal to x. Using the distributive property, then 3x plus 3 minus 7 equal to x. Then 3x minus 4 equal to x. By combining the likes, then 3x minus 2x equal 4. Then x equal 4. After finding the value of x, we can solve the second equation. Then y equal x plus 1, then y equal 4 plus 1, then y equal 5. After that, we can find the length of PR and SQ. Then we said here PR, this is 3y minus 7, then 3 multiply 5 is 15. 15 minus 7 is 8, and this side also is 8. Then here PR is 16. Let's find the length of SQ after finding the values of x and y. X we said is 4, then 4 plus 1 is 5. Then the whole length of SQ is 10. The last theorem, if we have 3 or more parallel lines and there is transversal, cut them and created congruent segments, then the other transversal they will do the same. That means BD equal DF. Let's solve this question. In the figure, marked lines are parallel. We have parallel lines AE parallel to BF, parallel to CG, parallel to DH. Let's find if we know that AB equal BC equal CD equal to, here we have congruent segments according to our theorem, then the other segments that created by this transversal also are congruent. EF congruent to FG, congruent to GH. Since we have in the given that EF equal 2.5 and we said that all these segments are congruent, then we can find the length of EH by adding them. 2.5 plus 2.5 plus 2.5, we will get that the length of EH equal 6.75. By the same idea, let's solve this question. EF, if we set EF equal FG equal GH equal 6 and AD equal 15. Since we have congruent segments created by this transversal, then here we have also congruent segments. Then AB equal BC equal CD. Since we have AD equal 15, then AB equal BC equal CD equal 5. The special parallelograms. Rhombus is a parallelogram with 4 congruent sides. A rectangle is a parallelogram with 4 right angles. The square is a parallelogram with 4 congruent sides and 4 right angles. Let's solve this question. Is the parallelogram ABCD rhombus, rectangle, or square? Since here we have angle B, right angle, and this is the parallelogram, then each two opposite angles are congruent. Then we have 4 right angles. Then this parallelogram is rectangle. The second question. Is a parallelogram EFGH rhombus, rectangle, or square? Since here in the given we have 2 congruent sides and this is the parallelogram, then each two opposite sides are congruent. Then we have 4 congruent sides in the parallelogram EFGH. Then this parallelogram is rhombus. Rhombus properties. If a parallelogram is a rhombus, then its diagonals are perpendicular And if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. Like this question, for example. Here this is rhombus. What are the measures of the numbered angles in a rhombus ABCD? Since this is rhombus, ABCD is a rhombus, then the two diagonals, the diagonal AC and BD, both of them are perpendicular, making right angles. And the two diagonals bisect the opposite angles. That means angle 3 and angle 2, they are congruent. Then here, according to these properties, then measure of angle 1 is also right angle, is 90 degree. And measure of angle 2, this angle, by looking at this angle making letter Z with angle 58. Then measure of angle 2 and angle 58 alternate angles. Then measure of angle 2 equal 58. Since this is the rhombus and the diagonal bisect the opposite angle, H2 opposite angle, then this opposite angle, angle D, bisected. That means they divided into two equal angles. Then measure of angle 3 equal measure of angle 2 equal 58. To find the measure of angle 4 from the triangle that given angles 1 and 3, and we said measure of angle 1 90 and measure of angle 3 58, then we can find the measure of angle 4 by subtracting the given angles from 180 to get that measure of angle 4 equal 32. What are the measures of the numbered angles in the rhombus PQRS? Here we have diagonal PR, and we know that PR, this bisect the angles, the opposite angles, bisect the angle P and bisect the angle R. That means measure of angle 1 equal measure of angle 2 equal measure of angle 3 equal measure of angle 4. Because this is a parallelogram and each two opposite angles are congruent, that means the measure of angle P equal measure of angle R, and the diagonal PR bisect the opposite angles. Then measure of angle 1 equal measure of angle 2 equal measure of angle 3 equal measure of angle 4. We can find the measure of angle 1 and angle 3 from this triangle PQR. Here this given angle Q 104, then we can find the measure of angle 1 and 3 by subtracting 104 from 180. Then the sum of measures angle 1 and 3, they have 76, and the measure of angle 1 after dividing 76 by 2, because we said these two angles are congruent, then measure of angle 1 equal 38. The same as measure of angle 1, measure of angle 2, measure of angle 3, and measure of angle 4. Because we said the four angles, they are congruent because this diagonal bisect the opposite angles. And the opposite angles, angle P congruent to angle R, angle S congruent to angle Q, each two opposite angles are congruent. The rectangle properties. If a parallelogram is a rectangle, then the two diagonals are congruent. That means AC equals the diagonal BD if this is a rectangle. Let's solve this question. If SF, this diagonal, equal 2x plus 15, and the other diagonal PR equal 5x minus 12, what is the length of a diagonal of a rectangle RSFB? Since this is a rectangle, then the two diagonals are congruent. Then the diagonal RB equals the diagonal SF. Then let's make substitution using the given expression 2x plus 15 and 5x minus 12. They are equal. Then by solving this equation, we will get that 5x minus 2x equal 15 plus 12. then 3x equal 27, then x equal 9. By making a substitution in any equation of those, let's make substitution in the first one as f equal 2. Instead of x we will put 9, then 2 multiply 9 plus 15, 18 plus 15 equal 33. Then RB equal SF equal 33. Next question. If ln equal 4x minus 17, MO equal 2x plus 13, what are the lengths of the diagonals of a rectangle LMNO? We said that the two diagonals are congruent. Then ln equal MO, then 4x minus 17 equal 2x plus 13. By solving this equation, then 4x minus 2x equals 13 plus 17, then 2x equal 30, then x equal 15. Let's make substitution in any one of them, ln or mo. Let's use this mo, for example. Then mo equal 2x plus 13, then 2 by 15 plus 13 equal 43. Then mo equal ln equal 43. Thank you for listening and have a nice day.